All right, at this point, you have all the tools you need to solve logarithmic equations. So in example 3, this is going to be an additional couple of examples. And I want you to approach this like you were on a quiz or another exam or even the final exam. Okay, if you see an equation like this, how would you solve it? Okay, so in example 3, it says solve each logarithmic equation, express irrational solutions in exact form, meaning no decimals, and also as a decimal rounded to 3 decimal places. Okay, in part A, our equation is 2 times the log of x minus 3 minus the log of 8 is equal to the log of 2. Okay, all right, first of all, it's an equation, so it makes sense to solve for x. It's a logarithmic equation because we have logarithms involved. We have logarithms on both sides of the equation, and they're all the same base. They're all log or base 10. Okay, so the goal here is to make it so that we have one single logarithm on the left and one single logarithm on the right. Okay, so on the left we have multiple logarithms. We have 2. We need to combine them into 1. Okay, so first thing to notice here, we're subtracting the logarithms, so we know subtraction turns into division. However, if you remember the rules for condensing, the first thing you need to check for is if there's a number in front. Okay, so this first logarithm has a 2 in front. The number in front of this logarithm is a 1, so it's okay. So you need to get this 2 out of the way. Okay, so again, we know if we have a number times a logarithm, we are allowed to take that number and move it up as the power on the quantity we're taking the logarithm of. Okay, so this is going to be log of x minus 3, that quantity squared. Okay, then minus the log of 8. Okay, now we've got one logarithm minus another logarithm. They're of the same base, so we can combine them into 1 through division. So this is going to be the log of the first quantity is going to be the numerator, x minus 3 squared. The denominator is going to be the second quantity, or 8. Okay, so that's how the two logarithms on the left correctly combine into a single logarithm. Okay, on the right side of the equation, we have log of 2. That's a single logarithm, so we don't need to combine it with anything else. I'm just going to carry it down. Okay, in this step, we have reached a point where we have a single logarithm on the left side, we have a single logarithm on the right side, and they're both base 10. The only way we can have one log equal to another log is if the quantities we're taking the logarithm of are the same. So we need to equate this quantity with 2. Okay, so in the next step, we're going to write that x minus 3 all squared over 8 has to be equal to 2. Okay, this is what we need to solve for x. Okay, so let's do this. Okay, it does have a fraction. Okay, so what we're going to do is get rid of that fraction. I'm going to take the denominator here, which is 8, and I'm going to multiply this side by 8. So now you have an 8 in the top and an 8 in the bottom, and they will cancel. But if I multiply the left side by 8, I've got to do it to the right side. Okay, so on the left side, 8 in the top, 8 in the bottom will cancel, leaving you with x minus 3 quantity squared is equal to 2 times 8, which is 16. Okay, all right, so going forward, okay, your instincts are probably like, let's multiply this out. Okay, so let's do it. This is going to be x minus 3 times x minus 3 is equal to 16, because that's what it means to square something. You've got to multiply the x minus 3 by itself. Okay, so you can either FOIL it or box it. I'll do it up here. X minus 3 times x minus 3. I'm just boxing this. So x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. Okay, so you can combine like terms along the diagonal. Okay, so these are both just x's. So we're going to get x squared minus 6x plus 9 is equal to 0. Okay, and then what we can do is factor. Oops, I forgot. What did I do? Hello. Okay, sorry. I multiplied out the left side. The right side is equal to 16. Okay. So at this point, what we can do is, this is clearly quadratic, so we need to move everything to one side. Okay, so I'm going to go ahead and move the 16 over. Okay, so I'm going to get x squared minus 6x minus 7 is equal to 0. Okay, so we need to factor or use the quadratic formula here. Okay, I'm going to attempt to factor this thing, so let's see what happens. The x squared will break down into x and x, and then we need two numbers that multiply to be negative 7, so let's try, and they need to add up to negative 6, so let's try negative 7 and positive 1. Okay, I think this should do it. If you check yourself, this should be x squared minus 7x plus 1x. Those will combine to give you the negative 6x, and then minus 7. All right, so that's the correct factorization. So we need to take each factor, set it to 0, and solve. So we're going to get x plus 1 is 0, x minus 7 is 0. Okay, so we get two potential solutions, negative 1 and positive 7. Okay, they both need to be checked in the original. Let's start with negative 1. Okay, so I'm going to come over here. And again, you're worried about plugging in a number and causing that causes you to take the logarithm of a negative number or of 0. Okay, so if x is negative 1, we're going to get, notice this logarithm is just, you're taking the log of a number. This is the log of a number. This is the only logarithm that you have an x in. So this first piece is going to be 2 times the log of negative 1 minus 3. Okay, so that's going to be 2 times the log of negative 4. Bad, bad, bad. Okay, can't take the logarithm of a negative number. Okay, so negative 1 is extraneous. Okay, we have to get rid of that solution. Okay, let's check 7. Okay, so if x is 7, plug it in. We're going to get 2 times the log of 7 minus 3. That's 2 times the log of 4. 4 is positive, so we're good. Okay, so the only solution in this situation is x equals 7. Okay, so I'll put it right here in a box. This is the only solution. Okay, let's look at the example in part B. Okay, so we have log base 5 of x plus 3 is equal to 1 minus log base 5 of x minus 1. Okay, logarithmic equation. Okay, we've got an equal sign, we've got logarithms. Both logarithms are base 5. Okay, so when you look at this, is it possible to make this a logarithm equal to a number, or is it possible to make it a logarithm equal to a logarithm? That's the question. Okay, so if I combine these, let's think about it this way. Okay, if I combine these into 1, okay, that would leave a number on one side. Okay, so it looks like it's going to be a logarithm equal to a number. Okay, why can I not make this a logarithm equal to a logarithm? Because of this 1. Okay, not all the pieces have a logarithm. Okay, so we're going to have to go with the option of one logarithm is equal to a number. Okay, so what I'm going to do, I'm going to start this by putting all the logarithms on one side. So I'm going to take this logarithm on the right here. It's negative, so I'm going to add it to both sides. Okay, so we're going to add this to both sides. And that means that the left side is going to become log base 5 of x plus 3 plus log base 5 of x minus 1 is equal to, on the right side, this cancels with this, so we're just left with the number 1. Okay, so now we have two logarithms on the left, just a number on the right. We need to condense the logarithms on the left side into 1. Okay, again, they're both base 5, so you can do this. Okay, We're adding the logarithms, so addition turns into multiplication. This is going to be log base 5 of multiply the quantities that we're taking the logarithms of together, okay? This is going to be x plus 3. That's a package deal, so it needs parentheses, times x minus 1. That's a package deal, so it needs parentheses as well, okay? This is how these two logarithms combine into one, okay? That has to equal the number 1, okay? Next, let's simplify what we're taking the logarithm of, okay? So log base 5, you have to box this or FOIL it, okay? So we're going to have x plus 3 times x minus 1, okay? This is going to be x times x is x squared, x times negative 1 is negative x, 3 times x is 3x, and then 3 times negative 1 is negative 3. Okay, so this is going to be log base 5 of x squared minus x plus 3x minus 3 is equal to 1. Okay, and if I go over here, I'm going to kind of clean up my work. So I'm going to get log base 5 of x squared minus 2x, or sorry, plus 2x minus 3 is equal to 1. Okay, we have one logarithm equal to a number. When you have one logarithm equal to a number, you do the arrow thing, okay? If I take the base, which is 5, and raise it to the first power, that is going to give me this quantity, which is x squared plus 2x minus 3. Okay, this is what I need to solve. Okay, logarithm is gone. If you scan this equation, it's quadratic. The highest power of x is 2. Okay, I need to put everything on one side in order to factor or use the quadratic formula. Okay, so I've got 5 is equal to x squared plus 2x minus 3. I'm going to subtract 5 from both sides. So I need to solve x squared plus 2x minus 8 is equal to 0. Okay, again, quadratic, so you need to factor or use the quadratic formula. All right, I think we can factor this one pretty easily. Okay, so I'm going to come over here. Okay, I think, let's see here, if I try to factor it, I need two numbers that multiply to be negative 8. They need to add up to the number in front of x, which is positive 2. So that should be 4 and negative 2. They multiply to be negative 8. They add up to positive 2. So this is going to factor into x minus 8. I did it again. This is going to factor into, I've got to use these two numbers. So x plus 4 times x minus 2. Okay, and you can check yourself. This is x squared minus 2x plus 4x, those combine to give you 2x, and then minus 8. Okay, we need to take each factor, the x plus 4 and the x minus 2, set them to 0. So we're going to get x is negative 4 and x is positive 2. Okay, these are the potential solutions. We need to check them out in the original. Okay, let's start with negative 4. Okay, so I'm going to come over here. Let me erase this. I'm going to do some checking. Okay, I will start with negative 4. Plug negative 4 in for x into the original equation. Okay, it's got a couple of logarithms. So let's see, if we plug this into the first logarithm, we're going to get log base 5 of negative 4 plus 3. That's log base 5 of negative 1. Absolutely doesn't work. You're taking the logarithm of a negative number. Okay, so you're going to have to throw this out. Okay, this is extraneous. Okay, so let me come over here. This is extraneous. Okay, so I've got to get rid of this solution. Doesn't work. Okay, now let's check positive 2. Okay, so if x is positive 2, I'm going to get log base 5 of 2 plus 3. That's equal to 1 minus log base 5 of 2 minus 1. Okay, so this is going to be log base 5 of 5 is equal to 1 minus log base 5 of 1. You're taking logarithms of only positive numbers, so that's cool. Okay, that means your only solution to this particular equation is x equals 2.